Please welcome our panel, hosted by our VP of Services for Digital Innovation, National Solutions, Matt Jackson.
Well, thank you to Brian and Joyce for great presentations. It's really exciting to hear some of our thought leaders, both within Insight and from the general analyst community, speak to all the exciting stuff that's happening around the intelligent edge. Brian, it was really interesting to hear about kind of the evolution and how a lot of enterprises and companies are thinking about the cloud extending out to the edge. And I know so much has changed just in the last few years. Excited to kind of dig into it with our panel of experts here. So without further ado, I'll go through some intros and then we can jump right into it. So I'm Matt Jackson, VP of Services for Digital Innovation at Insight. Really excited to have Brian Hopkins here, VP and Principal Analyst from Forrester, an expert that we've worked with in the field. So excited to hear both, from your keynote and then some of your perspectives. Juan Orlandini, who's our Chief Architect for Cloud and Data Center. Amal Ajankar, who is our Chief Architect for Intelligent Apps and Intelligent Edge. And then Brian Gacke, who's our Director of Services for our Connected Workforce. So a good variety of experts that can help kind of fill in the gaps around that journey to the intelligent edge. This has been, I say journey, and it's interesting. Little anecdote, I remember when we first started to do IoT work, this was probably 7-8 years ago when it started to really pick up. And we were starting to work with clients, talking about how innovative it was, how disruptive it was going to be. And one of my colleagues chimed in and he said, listen, I started my career at NASA right after the Apollo missions. We've been doing IoT since the 60s. This is nothing new. And I couldn't argue. It really is something that's been around for a while, but it's evolved a lot in the last 5 years. And I think the difference between what we kind of talked about with IoT, whether that was back in the NASA days or even just, connected devices a few years ago, and now what we're calling intelligent edge, is fundamentally different and really leveraging a lot of recent innovations in technology to make the edge intelligent. So with that as context, I want to jump right into some Q&A. I'll start with you, Amal. You've been on this IoT journey with us for a while, right? Ever since we really started to engage clients around some of this work. I remember each of the projects, whether it was a number of years ago or even recently, typically it kind of starts with some vision or a visionary within an organization who they're trying to gather data, they're trying to make informed decisions based on that data. But over the years, how have you seen that evolve from those early efforts into what we're calling intelligent edge today?
Thanks, Matt. So when I've engaged with customers back then, you were right. They just wanted to collect data and they wanted to visualize the data, and that was it for them. And they had some business outcomes that were related to that, but they weren't really thinking on a broader scale at that point. They just wanted the data. But now, with the edge become more powerful, the cost is reduced, and with innovations in ML and AI, that data is now become even more important. So now we can actually, when we are talking to customers, we are talking about the business outcomes. We are talking about how they can get the value out of that data instantaneously, right there where the data is generated. And that is where the edge is really coming into play, because now we can run or execute those models right where that data is generated, and be able to give them really in really low latency, near real-time insights into what is happening around the shop floor, on the manufacturing floor, in the retail store, in different use cases across industries. And I think that that key, innovation in hardware and being able to run AI models, be able to integrate into other systems, and amazing connectivity innovations that are happening is really transforming how we see a solution. Earlier, it was either in a data center or in the cloud, and now we're really seeing that change where data can be generated anywhere and it can be processed anywhere.
Great. Yeah, and I totally agree. It's amazing how much additional insights you can gain from that data now. Juan, again, on this theme of the journey, I mean, you're an old data center guy, pulling wires and thinking about like kind of the core infrastructure. So some of this may be new, but some of it's probably like just the same thing, different place. What does it look like, to take the intelligent edge and make it live, whether it's kind of that macro edge, micro edge, cloud, data center? Tell me about that kind of journey from traditional data center to now this edge.
Well, and thanks for calling me old, Matt. I appreciate that. And, the way you really should think about it is that the edge is now the data center is at the edge itself. It might be a very small data center, but the computational power that's available now at the edge is similar to what we had in the core data centers not just too long ago. And what's really exciting about that is that the number of use cases that you can deploy now from a single set of devices is grown exponentially. We've had instances where clients started a project with just a single insular vision of what they wanted to do with that, but they had so much spare capacity in the equipment that was laid out that they were able to leverage the same investment for additional use cases and additional insights into how to operationalize their business better, or how to improve their business, or even offer new services to their clients. So the edge, it's everywhere. The data center is everywhere. The network is everywhere, and that's really what we're talking about, is that interconnectivity between all of those devices and that computational power available.
Yeah, absolutely. And I didn't mean to call you old. I just meant like you've seen it all. How about that? So Brian Hopkins, this intelligent edge term that we're throwing around, that's not some kind of industry standard term out there. That's something that Insight uses, I think, to describe these types of solutions. But like, how do you see this playing out in the real world? You get exposed to a lot of different types of solutions. Any advice for those interested in going from maybe what we'll call basic IoT solutions, where they've started to connect some devices, started to get some data off of it, into what we call intelligent edge, really just more advanced processing at the edge?
Yeah, there's a couple things. So first off, we actually did start using the word intelligent edge in some research that some colleagues of mine published. I went and looked that up. So it is becoming more of a standard industry term. And as we saw in the keynote that I gave previously, execution of AI and machine learning for real-time customer and employee engagement is like the number one reason for edge. So we think that term or that idea holds water. Right. So you ask, what do you need to do to get ready? So I think the first thing you need to really think about is, does your network support it? One of the things that we see that's different between IoT of the 1960s, 70s, 80s, 90s, 2000s, and what we're talking about in edge is that we now have, through software-defined everything, software-defined infrastructure, software-defined networking, the ability to do things at the network level and the kind of high bandwidth, even wireless networking connectivity that we never had before. So if you understand the right kind of software-defined networking, virtual networking function technology, you can start to think about deploying these different workloads in little packages or containers into various edge environments. And we talked about those edge environments in the keynote that I did. So there's a big networking component to this, which means your software developers often find themselves dragged into understanding the nuances of SDN, which is not something that software developers, a lot of them, know how to do. The other two things I'd say very quickly that you need to really start to understand to figure this out is, what AI ops really means. A lot of the execution of machine learning at the edge, that vision that you hear, we see quickly bogs down when you have to make a particular machine learning model from a Python library or that you've developed in TensorFlow actually perform on different hardware environments. So there's a lot of pre-compiling, simplifying the neural network, training, hyper-tuning the model that happen after that model's been trained. And data scientists typically don't like to get involved with, how do I make this model function on this particular piece of hardware? You're going to need to know how to do that. And that drags in a lot of the networking pieces, because there's a lot of data back and forth that happens during that process. The last thing is, I think you need to get ahead of, is this whole idea that intelligent edge enables better distributed or federated type machine learning, or not all the data has to go back to the data center or the cloud to update or to retrain the model. There's a lot of things happening in research today about how models can monitor and train themselves, or share learnings between models deployed in different regions of the country or the world. That's a really interesting subject of research right now that's coming at us and will be enabled by the intelligent edge. So you got to think of that thing too.
Yeah, the great advice across the board. It's fine. I think we were talking with a few of your colleagues as well, and talking about some of the real world case studies. And I don't know if it was you or one of your colleagues interrupted, and they're like, "Okay, just tell us which ones are real, which ones actually made it to production, not just kind of pilots."
Very few. Very few.
Very few.
Very
And I think good for the audience to know is that these things, they can be fun and they can be interesting, and I don't want to say easy, but you can get them into some pilot MVP type mode. But getting them operational in a real world environment is a whole other story. And so hopefully throughout the course of today's discussion, the breakouts, we'll dig into that a little. Brian Gacky, I know your business, manages devices in the field. We have managed device offerings, and you've got a lot of experience supporting IoT solutions in reality, in the real world, real world conditions. Any common characteristics that you see that actually supported getting it from that pilot mode to production? Is there anything that you see as being kind of critical success factor in getting something like this live?
I think what we see a lot of is, clients getting to scale. In the pilot, you often are well equipped. You have a lot of smart people working on things. But when you go to production, one of the things that we constantly work with clients on is availability. It's not even a very sophisticated thing, but availability of devices that are going to go down. Because now we're talking about scale of thousands, hundreds of thousands of devices at times. And all of them working interoperatively, or in all of them making money, by the way. So in a quick serve restaurant, there can be 10, 20 devices that when one goes down, we're losing money. And so our job is to really help clients as they go from pilot to production to think about the forward and the reverse logistics. How many are going to be available where? Who knows how to put them back online? How do we deal with the device that's a little more sophisticated that has data on it, or things like this? So this is a whole life cycle that when you go to scale becomes a big deal.
Yeah, absolutely. It's important to talk about that life cycle, because it's not just getting it deployed. It's these tend to be devices that are exposed to real world environments, like in a restaurant or even outdoors, and you need to think about the whole life cycle of those. How do you replace them when they go down? How do you monitor them to make sure that when they go down? So Amal, I'll throw this one to you. We've heard a little bit of about the success criteria that go into making these work in production. But we know from what Brian Hopkins said that a lot of them fail, or a lot of them don't make it that far. Maybe without naming names, right? Tell me about a scenario of one that failed that you think is representative, so the audience can get an idea of like what might lead to success, but then what also might be some of those characteristics of these, I won't call them failed projects, but pilot projects that don't make it past pilot.
Absolutely. And there is one that comes to mind. We had defined the business outcome. There was value in doing it. From a technical point of view, we actually had it working as well. So we thought, great, everything's in place. And the use case was pretty simple. There was a drone that used to fly around wind turbines and inspect the blades for issues there. And our customer had the model as well, and the model worked great. We had good accuracy. All of that was fantastic. When it came to scale, we realized that to actually get the ROI out of it, we didn't want the human intervention in there, which meant we had to go back to FAA and pitch why this drone should be able to fly on its own without human intervention. And that took a long time. And I think it's still there in that pipeline. So even though sometimes there is a technical solution, there is a business outcome, but an edge solution will have so many different facets of operability, essentially, to make it productionized, that we have to think about those as well. So it's not just the technical solution, but it's, like Brian mentioned, how are you going to maintain that solution if it's out in the middle of nowhere? And if it's anything to do with drones, if it's anything to do with any other autonomous, vehicle, do we have the right permits? can we go and actually deploy this without putting anybody else in danger, right? So here the use case, the business case was, hey, if I don't have to send somebody out in the middle of nowhere to inspect a wind turbine, and I can have this drone sitting nicely in an enclosure, go and fly and do it, give me back my insights so that if needed, I can go and fix it. Well, if I cannot fly that drone autonomously, that means I need to be able to I have to send someone to fly the drone. And if I have to send someone to fly the drone, that means I've already spent the money, right? So there goes the ROI on that use case. So it might not always be that that technology is the problem. It could be regulations. It could be other environmental conditions that have to be taken into consideration before we can say, hey, this can go into production and it can scale out.
Yeah, it's a great point. People don't think about things like regulatory, issues, permits, but these intelligent edge solutions, by definition, exist in the cloud and in the digital world and in the physical world. And if you haven't thought through the repercussions of both, I've seen a lot of folks that come from maybe the software side of the house and they want to build an IoT solution, and they don't realize it could be regulatory, it could be just the amount of time it takes to do the electrical and mechanical engineering around hardware and then get it built, and then dealing with international supply chain and deliveries and installs and all those things that may not come into play in a typical software solution. Another huge topic when we talk about intelligent edge is security. I know that's top of people's mind, or it should be at the top of their mind, because you're putting these devices out there that are endpoints that can be hacked, they can be accessed. So Juan, this is a big topic for you and your team. Tell me about what people should be thinking about when they're putting devices at the edge. Are there any key best practices so that data doesn't end up in the wrong hands?
Well, it's a great question, and it's a rich subject of discussion because it starts actually at the development of the device or the sensor or whatever it is that you're putting out in the field. So you have to have security built into your development practices and make sure that the platform itself is built so that it's secure from there. But then you go into the network security, and Brian mentioned that as the software defined and all that stuff that needs to include all of the policies and procedures, and there's regulatory rules that we have to follow as part of that as well. And then once it's in the field, you also have to have physical security itself, a completely different aspect. And you got to make sure that, hey, if I have a device out there and it gets picked up by somebody, they're not going to steal my data, or even have that device become a vector for attack into the rest of the network that it connects to. So it's a bi-directional network security and all those other things. So it's the simplest way I could put this is you got to start with the very beginnings all the way through the very end and continuously monitor it. And that monitoring, tuning, testing, validation, it's not a point and test. It's a continual process that's built into the life cycle of your edge solution, whatever that ends up being.
Yeah, absolutely. No, good point about the whole life cycle. And I guess I'll throw it back over to Brian Gackey. Juan mentioned physical security. There's a lot of vulnerabilities that have been exploited. Whenever we hear about one of these big hacks, you can often trace it back to somebody hacking the network, stealing credentials, and then using that to get in to a system. But how do you kind of institutionalize that? Like, if you think about how you're provisioning devices, deploying, and securely managing them, what type of operation needs to be set up to support an IoT or intelligent edge solution in production?
Yeah, you again, back to the forward and reverse logistics, and depending on the sensitivity, the data that might be on the device, you could go to extreme measures. You could have very secure lab environments that prepare, and then some sort of secure shipping leg that gets it to the location with a credentialed tech that can only handle it. And right, so some of this actually exists in banking and so forth. Sometimes it's a little more loose, but there's so many physical things we have to consider. Even Juan mentioned the platform of the device and the way the OEM has developed it. A lot of times these devices still have ports on them, and we have to remove those ports physically, right? Because in fact, the sensor is accessible to the public, and someone could plug something in quite unnoticed. So there's just so many things to think about in that design. Also, reverse logistics, again, very sophisticated devices now. OS is retaining a lot of information. So a lot of that concepts of wiping. And now with some of the more modern systems management platforms that we're using, particularly when the edge is virtualized a bit, we can send a kill to the device, a wipe to the device. So there's really a lot of things to think about physically that, we got to go through that process when we're designing the full architecture. I agree with Juan. You do want to think about the devices because it's often not thought of. Look around at how many devices you see out in the wild and you're thinking,
No, it can be scary, honestly, as we think about what this means, when you actually, not just taking it to production, but then dealing, with the management of it, the operations. So I do want to end this panel, though, on a fun note. And so I want to pivot a little bit. We've been talking about what intelligent edge means in the real world and everything that we have to do to be successful. But, we've got a panel of tech experts that are always thinking about the next big thing. So I want to do a quick rapid fire. And just tell the audience what you think is going to be the next big innovation or disruption that's going to cause us to go to that kind of the next stage of the intelligent edge. So start out with you, Amal. Again, quick hit. What do you think people should be thinking about as the next disruption in intelligent edge?
I think AI is now pervasive, right? Everybody's thinking about AI. I think the next thing would be a tiered AI system where inference from one system goes into the other's system, and then it gives you better and better results or different outcomes. And then innovations in the machine learning model themselves so that you can actually run those on even smaller and smaller devices using tiny ML. Yeah. And so every device that you'll see in the next couple of years will have some form of AI running on it.
Very nice. Cool. Okay, Juan, how about you?
Well, I'm going to touch on something that Brian H. Covered on, and that's the network is really the key innovation. And I can't stress how much pervasive, high bandwidth, low latency networks are going to transform this stuff. Yeah. So 5G, satellite, and all those other things that are coming out that are going to give you connectivity that enable things that are similar to what the internet did for us in the 90s, right? Where all of a sudden that exploded and use cases that we hadn't even thought about showed up on the scene. That's exactly what's going to happen with the intelligent edge and the connectivity that's coming down the pipe for us.
Great. Brian Gacky.
Well, I was going to say 5G too, but okay. What I see in the retail sector interests me, and that is the interoperability of the IoT device and architecture with the customer's presence, maybe their presence in an area of the store or their smartphone. And so I think that will continue to evolve into wearables as we proliferate into bigger and better wearables. I think its interaction with the IoT and having this better experience is something we will see in the future.
Yeah, great. And Brian Hopkins, I want to end it with you and maybe your both kind of projections for what's going to disrupt this field, but also maybe anything else that we might have missed, any best practices that we didn't cover that you want the audience to take away as they go into those breakouts and dig deeper into all these different topics.
Hey, I'm sorry. Was that that directed to me? I had my mic glitched literally, and everything was dark for like.
No, perfect timing. You're back. Yeah, I'll turn over to you for the closing.
Yeah, for the final close. Okay. Well, I want to answer the question about disruption because we wrote one of the trends we identified last year is really interesting is how we think software is going to be able through AI is going to be able to code itself. In other words, AIs are going to be able to produce software in the ways that today we're using machine learning and AI to create AI models. So AI is creating AI using brute force kind of methods to discover the parameters to tune these machine learning models. Well, it's not too far of a jump to say at some point, and this may take 5 or 10 years, these AIs, these bots are going to be able to, through brute force testing, discover how to create highly performant middleware code. So software is going to start programming software eventually. I think the biggest application of that at some point, I mean, we're talking maybe a decade, but maybe not, is for systems that are built intelligently to discover dynamically what's happening in a particular edge context and create that middleware software that ensures performance and engagement in that edge context. So it's it's kind of like a meta software layer that's going to, where these agents were going to be able to dynamically create code for particular edge contexts, right? So there's all kinds of applications for that we are only now starting to really think about.
Yeah.
Right.
Yeah, it's a fascinating topic. It's a fun one to end on. It's kind of like when does artificial general intelligence come into play here? And you say 5 or 10 years, but I think all of us expect to be around then and probably still doing this type of work then. So you talk about disruption. I can't think of anything that would be more disruptive, especially for a lot of the people at this conference, than AI that builds AI. Or code that writes code. So fun to think about. I think we can probably put that in the back of our minds at least for a couple of years. But we always need to be thinking ahead and dealing with that next thing that's going to disrupt it. So really interesting conversation. Can't thank all of you enough for participating, shedding some light on this journey from kind of IoT to the intelligent edge. For everybody watching, strongly encourage you to attend the breakouts. We'll really dive deep into a few of these topics. Got some great presenters that you can watch immediately following this or at your own leisure. But thank you again for participating. Great conversation.
Absolutely. Thanks.
Thank you.
Thank you.